Hello students, in last session we studied about the aromaticity and Huckel's rule. After the completion of this aromaticity, now we switch over to the new topic is methods of preparations of benzene. So in our NCERT textbook they given a three different method. So first method is about the cyclic polymerizations of ethyne. As we know that the cyclic polymerizations of ethyne we have to discuss in our alkyne sessions. Okay, in the case of alkyne we have to take a 3 mole of acetylene or ethyne. We have to pass this vapor into the ion tube at 600 degrees centigrade temperature. So it's converted into cyclic compounds like benzene. So it's the most important method to form a aromatic compound from aliphatic compound. So that is this topic is discussed in our prior portion. Then we move to the another point is a decarboxylations of aromatic acids. The meaning of decarboxylations means we have to remove carbon dioxide. And mostly in the case of decarboxylations, most of the reactions of decarboxylations which can be carried out with the help of soda lime. So we have a compound is benzoic acid, and this benzoic acid when reacts with a sodium hydroxide, as we know that this benzoic acid is acidic in nature, so minus plus, and it's a base in nature, plus and minus, right? So Na is attached with this minus and OH, so water is released and we get a product is sodium benzoate. Our textbook starts from this intermediate product, okay? But first we have to take a benzoic acid, NaOH in presence of calcium oxide. Here 3:1 mole ratio is a mixture is used, is called as soda lime. So main role of NaOH means main role of sodium hydroxide, they are basic in nature, so they form a salt, and this salt further with the help of NaOH, so it's converted into Na2CO3. Mind well, this Na2CO3 and hydrogen is attached to this phenyl ring and it's converted into benzene and sodium carbonate is released. So simple is the CO2 is released. What's the trick portions of this benzoic acid? You have to remove simply CO2, so you get a product is benzene. So this is one of the product, one of the method who form a benzene. Then the reductions of phenol. As we know that the structure of phenol is like that. Benzene ring and OH group is directly attached with the benzene ring, is called as a phenolic group. When it reacts with a zinc, we know that the zinc is a very good oxidizing agent, right? So it's converted into ZnO and benzene we get from phenol. So various process or various methods to form a benzene, but actually in our textbook they demonstrate only 3 methods. Then we move to the physical properties of arenes. As we know that all the hydrocarbon compounds are non-polar in nature. It means that if the compounds are non-polar in nature, it means number 2, they are usually colorless liquid or solid with a characteristics aroma. Not soluble in water because they are non-polar in nature, but soluble or miscible in organic solvents like carbon tetrachloride, petroleum ether, likewise. And they burn with a sooty flame. This is the characteristics of aromatic compounds, because all aromatic compounds mostly burns with a sooty flame. But there is no discussion about the melting point and boiling point in our textbook, but the melting point and boiling points of arenes increase with increase in the molecular size due to the corresponding increase in the magnitude of van der Waals forces of attractions. As we know that, for example, if I having a benzene and number 2 toluene, so compared to the toluene, benzene having a lower molecular mass, so the melting point and boiling point of toluene is compared to the benzene, they are higher in nature. But this melting point and boiling point which cannot be included in our NCERT book, just for your knowledge. Now the most important point is the chemical properties of arene. As we know that arenes are highly unsaturated hydrocarbon but behave like a saturated hydrocarbon due to aromatization. So they are however more reactive than alkanes but are less reactive than alkenes and alkynes. So this lower reactivity of arene is because of the extra stability associated with this molecule is due to the delocalizations of pi electrons. Some important reactions of arenes are substitutions or replacement reactions, addition reactions, oxidation reactions. So these are the main features of a arenes. But firstly and most important reaction is a substitution reactions. What is the meaning of substitutions reactions or replacement reactions? Reactions in which one or more hydrogen of the benzene ring are replaced by the other atoms of group is called as substitutions reactions. In our textbook, there are 6 different types of substitutions reactions are given. Number 1, nitration. The meaning of nitrations means we have to add a nitro group in benzene and removal of hydrogen is called as a nitration. Same way, if we introduce SO3H, so it's sulfonation, halogenation, likewise fluorine, chlorine, bromine and iodine, but mainly chlorine and bromine. So it's called as chlorination and bromination respectively. Then after Friedel-Crafts alkylation, in this case we have to introduce alkyl group like methyl, ethyl, whatever. So it's called as Friedel-Crafts alkylation because invented by two different scientists, Friedel and Crafts. Next one is Friedel-Crafts acylation when we have to introduce acyl group means COR group is called as an acylation group. So 6 different substitutions reactions and mainly electrophilic substitutions reactions that we have to use. But before we start about this such a type of 6 reactions, first we focus on the mechanisms of electrophilic substitutions reactions. As we know that benzene contains pi electron clouds, one lying above and the other below the plane of the ring. So as compared to the sigma electrons, these pi electrons are loosely held, so they are easily available for electrophile. So in other words, benzene ring is act as a source of electron means nucleophile, and they attracts electrophile, the electrophile who repels nucleophile. Thus, the reactions of benzene and other arenes are initiated by electrophiles. As we know that electrophile substitutions reactions can in principle be either substitutions or additions. But whereas benzene and other arene undergoes electrophilic substitutions reactions, but alkenes undergo electrophilic additions reactions. Okay, so the mechanism of all the electrophilic substitutions reactions is basically the same and processed through these following steps. What is the first step? Now the most important step is the first step is a generation of an electrophile. What is the meaning of generation? First of an electrophile is generated as a result of some preliminary reactions. For example, if I am having a certain type of reagent E and Nu, E means electrophile and Nu means nucleophile, but they are neutral in nature. So in this case, your nucleophile, because it's a more electronegative compared to the electrophile, so they attract electron towards to them. But this process is done through such a type of catalyst. It's not a autonomous reactions. Okay, so it's converted into E plus and Nu minus. E means electrophile and Nu minus means nucleophile. Okay, then number 2 step is the formations of carbocation intermediate. As the electrophile, this electrophile now approach the benzene ring, as we know that this benzene contains 2 pi clouds, one lying above and other the below. So they attracts towards to the benzene ring and it's attracted by the pi electrons to form a sigma complex. So how this electrophile, so it's a mechanism. So first this electrophile, they attracts towards this pi electron cloud. It's a very slow step, so it's a rate determinating step. So the name of this reaction is called as an electrophilic substitutions reaction. So E, H and E. So now because if they lose electron, so there is a deficiency of electron on this carbon. so it's converted into carbocation. But as we know that in the case of this carbon resonance hybrid suggests that now the pi electron shifting and it's converted into this particular carbocation and next position is at here. So overall, because it's a canonical structures, but as a hybrid structure, your E and H, and partially delocalizations over this part. So it's called as a sigma complex. So the sigma complex slowly reorganize or rearrange to form a sigma complex or a carbocation intermediate, which is stabilized by a resonance process. After this resonance, there is a loss of, during the formation of the sigma complex, the aromatic character, because mind well, this is the aromatic character of the benzene ring is destroyed. Now the delocalization of pi electron is not over the whole system. Therefore, this step is slow and hence is the rate determining step of the reactions. Now the third step is a loss of a proton from the carbocation. So it can lose a proton to the nucleophile. When nucleophile is attached with this H, so at that time they lose the electron. So now H plus is connected with nu and we get a product is like that. This is the fast step. So it can lose a proton to nucleophile presents in the reactions mixture to form a substitutions product. Because okay, fine. So what's the particular product? Benzene, and it's converted into this electrophile. So it's called as an electrophilic substitutions reaction. Since during this step aromatic character of the benzene is now restored, okay, so this step is fast and hence does not affect the rate of the reactions. First, the aromatic characteristics is destroyed, and now in this step is a restored. Okay. Some people says that alternative this nucleophile maybe attack the carbocation intermediate to yield the addition product. No, it's not possible, because this addition is however not observed, since during these addition reactions the aromatic character of the benzene is lost. So they convert into, or particularly restorations of this aromatic character. So most of we have search this type of the reactions, not these reactions that we have to found. So these additions reactions is not possible. So this is all about the common electrophilic substitutions reactions. Now we switch over to the next portion is a different reactions. First one with the help of nitrations, then sulfonations, chlorination, bromination, Friedel-Crafts alkylation and Friedel-Crafts acylation in our next session. Thank you very much.